analysis contents. Contents 30.1 Introduction, 30.2 Starting and exiting SPSS, 30.3 Creating a data file, 30.4 Univariate analysis, 30.5 Bivariate analysis, 30.6 Multivariate analysis, and 30.7 Tests of significance, and 30.8 Conclusion. Learning objectives. It is expected that after going through Unit 30, you will be able to understand the use of SPSS in your data analysis, start and exit SPSS program, enter the data into the SPSS data editor, import a data file from Excel program. So 30.1 Introduction. SPSS, Statistical Package for Social Sciences. It's a computer software program, provides access to a wide range of data management and statistical analysis procedures. This program can perform a variety of data analysis, including tables, statistical analysis, and graphical representations of data. Also, SPSS is particularly well suited to sample surveys research. It is assumed here that you have a basic understanding of the basic concept and technique of statistical analysis. See the units of block 5 in book 2. You have also learned how to collect, edit, and code data for analysis. In Unit 30, you will learn how to use the SPSS to perform data analysis. You can run SPSS program on a personal computer within the Windows 95, 98, 2000 or XP or NT operating system. Since it is a window-based program, you can use the program without any difficulty and more interactively like Word, Excel, or PowerPoint programs. The command instructions given and examples shown in this unit are Windows-based SPSS version 11.5. Please note that Unit 30 does not carry any information in boxes. It has plenty of graphics to understand the details without the aid of boxes. For reflections and action exercise, there are some straight questions for you to answer, as the reflection part of the exercise is going to take place during your reading of the text along with its graphics. It is a good idea for you to repeat the viewing of these graphics as many times as possible and practice using them to carrying out first simpler and later more complex tasks. 30.2 Starting and exiting SPSS. Normally, SPSS program will be located in the program folder of your PC. To start SPSS, click the left mouse button on the start button located at the lower left to the screen. A number of items will be listed on the screen. Okay, nowadays things have changed with Windows 10 and all. Still, I am going to read this same. Okay, so you can make it up. Select programs. So left side you can see select programs. So many programs will be there. So in that, the program menu, you will open the select SPSS for Windows for the programs menu, and then select SPSS 11.5 for Windows for the SPSS menu. So this is maybe old version, the latest version may be different. Okay, so click and release the mouse button. Symbolically, these actions are shown as select start program SPSS Windows, SPSS 11.4 Windows command from the start button menu of PC. Throughout this unit and Unit 32, we will be showing the symbol, this arrow, to indicate the director or steps you have to move your cursor with the mouse. Okay, from this step to next step, like that. First you have to click start, then you have to stick the programs, especially in Windows XP functional, it comes like this. And the programs, then it becomes SPS and Windows like that. So here it's a screenshot of this for first page of the desktop. Okay, so SPSS for Windows, in that this screenshot has been given. After a few moments, you will see the data editor window dialog box along with the SPS window menu dialog box asking you what you would like to do. So this is then when you click that SPSS for Windows, then a new page will open. Okay, so this is, it will ask, there is a column head will be there, menu will be there, menu bar will be there, toolbar will be there. So this is the different, then this is the different active cells like that is in Excel. So cells are there available. So this is 3.2 SPS for data editor. So exit SPS data editor whenever you have to finish the SPS and when want to quit it, then select file, exit command in the name. So in the top, if you go to file menu will be there itself. At the bottom you can see the exit menu to come out of the software. So this then next what we have to see is how to create a data file, that is 30.3, creating a data file. So normally the first thing you would like to do is to create a data file. For this, check mark on the toolbox and then click on OK button on the SSPS for Windows menu dialog box. The menu dialog box disappears from the screen, leaving the data editor on the screen. So okay, there is a button. Can't able to read this typo. So when we go to the software, then we can see this actually. Okay, when you click this button, then only data editor will be there. Then data editor help you to enter a series of data you have in a specified format required for the data analysis. Open an existing file, then edit the data, and converting other data files into SPSS data files will be active throughout your session of using SPSS data entry and data analysis. The data editor looks like a worksheet made up of the series of rows and columns. The intersection of a rows and column is called a cell. Then cell may contain a number of text. Each column will contain information data of each variable. Similarly, each row contains information or data for each case. The first row of the cell indicate at the top of each column is shared and contains a faint variable. So these cells contains the name of variable. Okay. Similarly, the first shaded column contains the faint numbers like 1, 2, 3. These are called the case numbers. The data editor dialog box contains a menu bar at the top of the window. The menu bar indicates broad categories of SPSS features called commands. This menu bar help you in identifying and selecting commands. So under your command, okay. Figure 30.3 menu bar and toolbar of SPSS data editor. The toolbar is below the menu bar and allows you, toolbar is below and the menu bar and allows you to quickly access the basic SPSS commands. By clicking on the respective button, you can access some commands which will interest you quite often. Observe the cell at the intersection of row in each case and column variable with the heavy border. The heavy border cell indicates that the cell is an active cell. You can enter or edit data in the cell. You can activate any cell in the worksheet by simply pointing the mouse cursor at it and clicking on it once. So this there is a lot of variable will be there. This is the different case numbers are there. Then if you click on this cell, you can enter the data. So this is very common nowadays. I think most of basic people who use Excel, they can understand this. So this is in figure, this is untitled SPSS data view. So there is no name as given, that's why it is called untitled. So there are two variable views available in the data editor, data view and variable view. In the data view, you can see the data the way you have typed. In variable view, you can see the properties of each variable defined. To access these variable views, click on the perspective buttons. So here you can see there is data view and variable view. So if you click any one of this, you can see it accordingly. To access these views, click on the respective button located at the left bottom corner of the data editor. It's not here, it's showing here properly. So this is in the left bottom. This is in the bottom side, bottom corner, data variable and variable view and data view. Entering the data into data editor. As you have learned earlier, your data may contain a number of variables. Examples of variables are sex, male or female, marital status, married or unmarried, widows, etc., income, attitude, likes, dislike, extra, a score, etc. Again, for each variable you may have a number of observation called cases. You have also learned in an earlier unit how to assign the codes to the qualitative data. For example, you have a data set containing information of 30 people on a sex distribution, age, marital status, and income. You also suggested the following codes for the data set. Sex distribution, male, we can give a code 1, female if it is number 2. Age in years, so that you can give whatever the number for that age. Marital status, for married you can give 1, unmarried 2, widows 3, like that. For incomes, that you can use that digit. The data you might have collected may look like as follows. So this is the age, you have given the actual numbers, and income also given the actual numbers. For these other options, you have given the assigning the numbers. Okay, so you will have a case in each case, the first case, second case, that's what is the different values available. The process of data entry to the data editor involves 4 basic steps. Define variables, okay, define labels, define missing values, enter the data into the cell. So if some missing value is there, that also we have to define it. But then if it is 0 means the data is not available, missing, no value available. So define labels means you can have like that, male 1, female 2, like that. We will explain these steps with the help of a data given in our earlier example. For this, move your cursor to the left bottom of the data editor and click on the variable view if the data editor is not in the variable view. Okay, so specifically if you go to define variables, so you need to define a variable to name it, specify the data type, qualitative, quantitative, number of decimal places, etc. Specify the data type. Okay, assign labels to the variables and data values, defining missing values, and specify levels of measurement, nominal, ordinal, interval, or ratio, scale. In addition, you can also define the column format for this. Active a cell in the first column by clicking on it. Click on the variable view button. The grid will change to a new format as shown below. For each variable you create, you need to specify all of or most of the attributes described by the column heading. Activate the first cell in row number 1, row 1 under name, column heading. Change the variable name, type the name of the variable, say sex, and then press enter key. Observe that the variable name sex replaces the default variable name var, and then the other cells of the first row and default properties of the variable will appear. So remember that a variable name can have a maximum of 8 characteristics containing only letters, or both letters or numbers. The first character of a variable name should start with a letter, then it contains numbers. There should not be any special character in the variable name. Also, in the same data file, no 2 variables should have the common names. Okay, so to change the type of variable, move the cursor to the second cell of the first row under the type column heading, and as small gray button marked with the 3 dots will appear. Click on it. The variable type dialog box appear on the screen. Notice that the numeric is the default variable type. If you have only numeric values for that variable, say sex variable, check mark the numeric box. You can enter the width of the number, the default width, 8 character like that in the width type, and sometimes you may need to enter a number with decimal places, enter the number of decimal, how much it can carry, so like that. Displays this places text box. So you can define that particular variable, how many decimals should be there, what type of variable it is, like that. All this kind of you can define that particular variable. Okay, setting is 2 decimal places. If your data contains only integer values, then type 0 in the decimal places, text box will be invalid. No, so if you have a variable string characters like name of people, places, etc., check. So that is string characters. So check mark the string button in variable type dialog box and enter the maximum number of characters that particular string variable can hold. Similarly, other data variable types such as date, currency, etc. can also be defined. Specify the level of measurement for the variable. For example, sex is a nominal variable by clicking the cell under measure column heading. So that is the thing, level of measurements. So how many step 2 is to define labels. Now you can assign text labels to the coded values of the variables. A variable label is a longer descriptions of the variable that can be included in the variable name you have defined earlier. This may be necessary since the variable name is restricted to 8 characters. So you have to describe it at later stages to understand the characteristics of the variable. To define labels, type the name of the variable, say sex distribution of person, in the cell under the label column heading. So move on to the cell under values column heading. Click the gray box with the 3 dots. Value labels dialog box appear on the screen. Type the numerical value assigned to the label under the value box and type the label name that you under the value the label text box. For example, you may type 1 in the value type box and a male in the value label textual box. To add the label, click add button. Again type 2 in the value type box and female in the value label text box, and then click add button. So this is the way you can assign different values to labels to different options of the variable. So continue this process until you add all the values and the respective labels. Sometimes you have a number of labels, number of options, so you can add those labels into that. Clicking OK button to close the value labels dialog box. Remember that you need to define the value labels only for categorical data. For the continuous data, this is not required. That is step 3, defining missing values. Sometimes your data may contain missing responses for a variety of reasons. Assign a missing value to the variable if necessary. For example, if the sex category of a person is not available, you may assign the value 9 to indicate the missing value. The missing value indicates to a Spss that the response is not available and should not be included in the data analysis. To define the missing values to the variable, click on the cell under missing column heading, and the missing value dialog box appears on the screen, and you can assign that value. If there are no missing values in the variable, check mark no missing values buttons. Otherwise, check mark discrete missing value button. You can type a number assigned by you as a missing value. For example, you may assign 9 if sex category of a person is not available. If you have check marked for missing value, type the assigned missing value, say 9 in the text box. Okay, so click on OK button to close the dialog box. Remember that the missing value you have assigned for a variable are present in their respective positions in data file. You can also specify the width of each column in the cell under column heading and alignment, right, left, center in the cell under align column heading. Specify the type of measure in the cell under measure heading. Measure, scale, or normal, like that, specifying under measure. You have to, now you have defined all the information for variables. Move on to the second row to define age variable, the third row to define the Marshall status variable, etc. To define the rest of the variables in that order. You have defined all the variables. You may like to see the generated variable definitions. For this, select utilities, file info, command on the menu bar. This will generate the file information in the output window, and that can be printed if you need for future reference, like that. This is the file information, like that, list of variables on the working file. These all the things you already entered into the sex. There is sex distributions, so that is the measurement level is normal, and column is 8, column width 8 up to 8, alignment is right. You have done the print form F1, writing return format F1, write format F1, missing values 9, and the labels are label values are 1 and 2, like for male and female. And for age also we have given different this thing, and Marshall status also we have given different labels, and income also print format and all those. This is the after just to see that what all we handed here. Then the step 4 is entering the data into the cells. Now your sheet is ready for spreadsheet or worksheet is ready now. So now you can start enter the data into the cells. Once all the variables of your data file are defined, the data can be directly entered into the cell. For this, first change the view to data view by clicking the data view button. Click on the cell 1 of the sex variable to activate the cell. Type the value of the variable, say 2, and then press the enter key. Observe that now a number 2 appears in cell 1 and number 2 in cell 2 and become active. So type 1 and enter key. This indicates that the value of the case of the sex variable is also entered. Continue this procedure until all the values for the 30 cases are entered for sex variables. Activate the case 1 cell below age variable column and also start doing the same thing. So you can enter the data for the all cases and all variables also you can do. For other variables also you can do. Okay. So once you have entered the data, it is good practice to save the data in the file. So you have to go to file and to save it. This will avoid not only repeating the data entry but also all the future uses of your data. So SPSS distinguishes between two types of files: data files within the extension of .sav and output files with the extension of .spo. The data files contain the data you have entered. The output file contains the output of the data analysis you have performed. You need to save these files in case you may need them for future use. So to save the data file, save as command from the menu bar, and save the data as dialog box appear on the screen as below, and whatever the particular directory you want to go and save it, and also you can give the name for saving. Select the drive and folder, then where you are interested that file should be located. Type the file name and text box under the file name box, click save button. Importing a data file from Excel sheet. Now we are all entering the data one by one. Now you can also import that this is all data from an Excel worksheet. You have already that details in Excel format. Then often you might have entered a data in an Excel sheet and want to use the same data set of analyzing the data using SPSS. SPSS can easily open an Excel data file and some other types of data files to open Excel data file. Select Start Program Microsoft Excel command from the Start button on your PC screen. In a few moments, the Excel worksheet dialog box appears on the screen. So select open command from the menu bar. The open file dialog box appears on the screen. Select the drive and a folder where the data file is stored. Select that file name and click OK. The Excel data shell will open as shown here. Observe what the variables names are at the top. Now let us assume that the worksheet has been saved as Excel with extension or .xls file called profile. So select file open data command in the SPS data editor dialog box. The open file data dialog box appears. Choose the appropriate directory and folder in look in file of type box. Select the file name profile.xl. You just open and show this here. So the file name is called profile and .xl. So you are just going and opening in SP. This is the Excel sheet. So this Excel sheet, you can just open it in the data command in the SPS data editor. It will be opening. This is the Excel book. So observe that the variable names at the top row. Let us assume that the worksheet has been saved as Excel with extension .xl file called file. Selection. Next, select open in SPS editor. The open file dialog so appears, and look for that particular file. Choose that profile.xls file name. You can just like this, you can just search for that file and you can click to open it. Click open tab in the open file dialog box. The opening of Excel data source dialog box appears on the screen. If your Excel file contains variable names, check mark read available names from the first row of the data box. If you leave the range box blank, SPS will read all the available data in the Excel sheet. If you wish to read only some rows and columns, then you can type the range. If you want to have a range in this many columns and this many row in your SPSS file, then you can do accordingly. I want only one row and 30 columns, or 30 rows or one column, like that. So click OK button to close the opening Excel data source dialog box and return to the data editor dialog box. Observe that the data in the SPS data editor save the SPS data file. Then you can open it, and also you can save it in that format. So qualitative. So the reflections and action 30.1 here. Answer the following two questions after going through the text above and viewing the graphics. The idea above answering this question is to make sure that you have understood the procedures. Explain briefly the various steps in creating the data file. Differentiate between SPSS data editor and output SPSS viewer. So this is the reflections and action. So now you go to 30.4 univariate analysis. So data can be analyzed in a number of ways. You can present the data in a simple frequency table or use statistical techniques for the analysis of the data. The data file should be opened first. If the data file is not already open, select file and go open command from the menu bar. Then the open file dialog box appears. Choose the file location and SPSS data file name and click OK button. Then the data may now appear in data editor screen. SPSS offers several tools to analyze the data. The tools are selected from the analyze command of the menu bar. In this section, you will learn how to generate frequency tables and calculate the univariant statics. Remember that you can compute the same statics in SPSS using alternative commands. So frequency tables, to generate the frequency tables. So select, you go to analyze descriptive statics frequencies command from the menu bar, and the frequencies dialog box appear on the screen with two large boxes for variable selection or deselections. Observe that the left box contains a list of variables for which data has been entered. On the right side there is an empty box for the variable that you want to include in the analysis. In the left side box, select the variables to generate a frequency table by clicking the mouse of the button's name of the variable. Click the arrow between the two boxes. The selected variable appears on the right side box. Follow these steps till all the variables you wanted to include for the data analysis appears in the right box. So this is the button. If you click whatever the variable from here, it will go here. If you want is, you can jump it from left to right like that. The frequencies. So which when the first variable is moved to the right side box, arrow in the opposite direction appears between the two boxes. If you commit a mistake by selecting a wrong variable, click this arrow to return to the variable to the original list. Remember that this frequencies tool is appropriate only for categorical data like that sex, martial status, and in our example. Therefore, do not select any continuous variable like age and income in our example. So when you have selected all the variables you want to include data analysis, click the OK button. In the output SPSS viewer window, you should now see the output shown below. Frequencies. So how many times the frequencies? So find the two tables 30.4 and 30.5 on sex distribution and a distribution of person and martial status respectively. So there is a distribution 30 people, valid is 30 people, missing is 0. Martial status also 30 people are there, that is the frequency 0 is missing. Here the martial status, sex distributions of person, male, female, frequency is 14 and female is 16 and total 30. So the percentage is this much and valid percentage also the same and cumulative percentage also given. So Martial status here also given. This is sex distribution. This is Martial status also, married and married also. How many other also frequencies was given, and the percentage or validity and cumulative was given. Observe that the table contain all the information you want. Also you have information of the missing cases for the each variable. You also have a 3 types of percentage, one for all cases including missing cases under the heading percentage, the second one for only valid cases under the heading valid percentage, and the third gives a cumulative percentage under the heading cumulative percentage. So this all the information gives. So printing and saving output. Now you want to make a printout or paper save a file for output available on output Spss viewer window. To save the output in a file, following instructions give at the saving data file. To print all the output, click anywhere on the outline pane located on the left side of the screen. Select panel outline, file, print command for the menu bar and click OK. To print a part of our output, move to the cursor to the end of the portion of you wanted to print. Press the shift key on the keyboard and click the left mouse button. Observe that the selection is highlighted. Select file, print command from the data bar, click OK. So record data. You may want to record your data for a variety of reasons. For example, the data values for the variable age continues. Now you may want to group them like this, like now I have entered different ages. So which all ages, how many people are in the age group between 20 and 30, like that. So this the data values also to record a variable, select transform record into different variable command from the menu bar. The record into the different variables dialog box appears on the screen. Select the variable you want to record in different variables in left side box. Transfer this variable to a right side box using arrow tab that lies between the two boxes. Type the name of the variable in the name text box and label name in the label text box. So this is recording the different variables like old and new values, like that. So press the old and new values button. They record into a different variable dialog box. They record into different variables. Old and new variable dialog box appears. Check mark the range button. Type the first range of values in the boxes under range. Check mark the values button on the new name heading. Press add button to define old and new values. Press continue button to close the record into different variables, old and new values dialog box, and return to the record into different variable dialog box. So the record into a different variables. So if you have more variables to redefine, continue these steps for each variable. Otherwise, press OK button to close the record into a different variable dialog box. Univariate statics. For each variable of your data sets, you can calculate measures of central tendency like mean, median and mode, dispersion, that is standard deviation, variance, range, standard error of mean, etc. and see distribution, that is kurtosis and skewness. Remember, in SPSS there are some restrictions on the choice of measures of central tendency, mean, median and mode, and that can be calculated on any data set. The choice of mean, median and or mode is restricted by the level of measurement of variable you have defined. If the level of measurement of a variable is normal, you can calculate only mode. If the level of measurement of a variable is ordinal, then you can calculate mode and or median. If the level of measurement of a variable is interval oblique ratio, you can calculate mode, median and or mode. To calculate the univariant statics, then you have to go to select analyze descriptive statics frequencies. From the menu bar, the frequencies dialog box appears on the screen. Transfer the variable of which you want to perform the data analysis from left side box to right side box, as you have done for frequencies analysis earlier. From here to here, like that. If you don't want to display frequencies, remove the check mark and In display frequency tables button by clicking, the SPSS for window dialog box appears asking you to confirm. Click OK button to close the window. Click on the statics button in the frequencies dialog box. The frequencies statics dialog box appears on the screen. In the area of under central tendency, check mark the appropriate button to calculate mean, median and or mode. In the area under dispersion, check the mark appropriate button to calculate standard deviation, variance, range and standard error or mean, etc. In the area under distribution, check the mark appropriate to button to calculate skewness and or kurtosis. So these are the different frequency statics. Click on continue button to close the frequency statics dialog box. Click on OK button in the frequencies dialog box to close it. Observe that now the output is descriptive statics. So all this mean, standard error of mean, standard deviation, variance, all are calculated here. So remember that you should opt for only appropriate statics. For example, there is no meaning in opting for mean of a Sx variable since there is nothing like mean of a Sx distribution. So reflections and action 30.2. You have just finished reading about the univariant analysis in which you worked on frequency tables and univariate statics. In the light of this information, answer the following questions. What is the command on the SPSS menu bar to perform the frequencies data analysis? Once the data has been coded and entered into SPSS data editor, is it possible to record the data? If yes, where is the command to record? You have defined the level of measurement of a variable as ordinal. Is it possible to calculate all the measures of central tendency for this variable using SPSS? Name the central tendency measures you can calculate. Now you look into 30.5, that bivariate analysis. Often you may be interested in comparing two sets of data or variables to explore the relationship between two variables. In this section, you will learn how to cross-tabulate the data, coefficient of correlations, linear regression, and coefficient of variance to compare the two variables. Cross-tabulation of data. To capture any possible relationship between the two variables measured with categorical data, you may use bivariant table, which is known as cross-tabulation. The cross-tabulation two variables follow the steps given below. Select, analyze, descriptive statics, crossbars, command from the menu bar. The cross-tab dialog box appears in the screen. Click the variable in the source list from the left side box. That will form the rows of the table. Shift this variable to the box under rows using row key and arrow key. Similarly, shift the variables that will form the columns on the table from the source list to the box under columns. Click OK button, you will find the table in the output viewers window. So cross tabs like that, sex distribution and Marshall status, these two things is the bivariant here. And this cases already 30 cases are there, 100% are real, so missing is 0 and total also 30%. The count here the sex distribution and as well the Marshall status in this 6 male married and 6 male unmarried and 2 widowed, and in female side it is 7 married and 4 unmarried and 5 widows. So this is the total married, unmarried and widowers given here. The total is coming up here the total number of males and here the total number of females. So sometimes you may be interested in calculating the row column total percentage in a table. For this, click on cells tab in the cross tabs dialog box before step 4. The cross tab cell displays dialog box appears on the screen. This is observed and this one is expected. Cross variable cell display. Check the mark the appropriate row column tab or total button Under percentage area, click continue button to close the closed table cell. Display dialog box, click OK button on the closed tabs dialog box to view the output. Close tabs. Tab 30.9 case processing summary output. So this is the way we have calculated as per the percentage wise, and the total 100% like that it's come. So bivariant statics, the statistical tools you often use to compare two variables may be the coefficient of variance, correlations, and linear regression. Coefficient of variance, as you are aware, the coefficient of variance CV is the standard deviation expressed as a percentage of the mean. Unfortunately, SPSS does not have the command to complete the coefficient variance for the variable in a data file. What we advise you is that you should calculate the respective mean and standard deviations of a variable using the descriptive dialog box as explained earlier, and then calculate CV by hand, which is very simple. So correlation coefficient, there are two types of correlation coefficient: Pearson's correlation coefficient, Spearman's rank correlation coefficient. The Pearson correlation is appropriate and applicable when you have interval or ratio data. Spearman rank correlation coefficient is applicable when you have two ordinal scales with a large number of values, or one ordinal and the other interval or ratio scale. To compute the appropriate correlation coefficient for your data set, follow the instructions given below. In the software, you in the menu bar, select Analysis, Correlate, Bivariant, command for the menu bar. From the menu bar, the Bivariant correlation dialog box appears on the screen. Select the variable by shifting from left side box to the box under the variable data. From here, it will be shifting what all variable you want to analyze to this side. Here the arrow button will be there. So from this check mark the appropriate, whether you want Pearson or in that which one you want, like that you can. Correlation coefficient, Pearson or null or Spearman's, whichever options are available, and test two-tailed and one-tailed, like that. So correlation run. If you associate test significance check mark appropriate to two-tailed or one-tailed button under test of significance area, you will see the result on the output viewer window like this. So this is the Pearson correlation coefficient. Linear regression. The linear regression technique is used to test the hypothesis concerning the linear relationship between the two variables, estimating the specific nature of relationship, and to predict the values of dependent variable when you know the values of independent variable. To run the linear regression procedure, follow the steps given below. Here also again in the software menu bar, you go to Analyze, Regression, Linear. The linear regression dialog box will appear in the screen. Click the variable names, that will depend variable, the left side box. Shift the dependent variable to the box under the dependent area using the arrow tab. Click on the variable names that will be independent in the left side box. Shift the independent variable to the box under independent area using arrow cap. So click OK button, you will see the result of the output viewer windows. Observe that the output consists of 4 points: a table of tables, variables used in regression, a model summary, an ANOVA table, and a table of coefficients. You may be interested in a portion of the output. We will explain how to select a partial output in another unit on use SPSS in reports writing. Regression. Table 30.12 variable entered or removed. All requested variable entered, dependent variable income. So this is the different model summary and ANOVA table, coefficients, like that we can calculate. This is the report which comes out of it. So now we will go to multivariate analysis, 30.6 multivariate analysis. Sometimes you may be interested in exploring the complex relationship involving more than two variables. In this section, you will learn how to cross-tabulate your data from the analysis of relationship between more than two variables. Similarly, how to compute multiple regression analysis has also been covered. Elaboration of cross tables. In earlier section, you have learned the cross tabulation of two variables. You can introduce a third variable by subgrouping one of the two variables. This can be done by introducing a variable as a control variable. A control variable decomposes the data into subgroups based on the categories of the control variable. To add a control variable for your cross tabulation, follow the steps given below. Select Analysis, Descriptive Statics, Crossbars command from the menu bar. Then the cross tabs dialog box appears on the screen as shown in the next page. Click on the variable in the source list that will form the row of the table. Shift this variable to the box under rows using arrow key. Similarly, shift the variable that will form the column of the table from source list to the box under columns using arrow key. Click on the variable which will act as a control variable. This variable split the variable selected at step 3 into a subgroups. Shift the control variable to the box under layer 1 of 1 using arrow key. For computing the row or column total percentage just in the variable. Click on cells tab. This cross tabs cell display dialog box appears on the screen. Click the appropriate row, column and or total button under percentage area. Click continue button to close cross tables cell display dialog box. Click OK button to close the cross tabs dialog box. Cross tabs 30.16 case processing summary. Let us look at the table 30.17 income group and sex distribution of personal and marital status cross tabulation. You will find that cross tabulation of marital status by income group of married and widowed persons with their sex distribution. This is a good example that you can try and use in your own research work. Now, not only this, but you can also use other examples given in this unit for your research project. So there is 3 variables like that: income group, income, sex distribution and marital status. So you can see this 1, 2, 3 income groups. This is subgroups of married income group. Income groups married and widows. So this created a subgroup. This is the sex distribution of that. So multiple regression in 2 variables linear regression, you have used one dependent variable and one independent variable. The multivariate regression is used to investigate the relationship between 2 or more independent variables on a single dependent variable. The procedure for computing the statics for multiple regression is the same as that of 2 variable linear regression explained earlier. Expect that you have more than one variable under independent area in the linear regression dialog box. So again, in the menu bar, go to Analyze, Regression, Linear. Then Linear Regression dialog box will appear. Click the variables name that will be a dependent variable in the left side box. Shift the variable to the box under the dependent area using the arrow tab. Click on the variable name that will be independent in the left side box. Shift this variable to the box under independence. From here to here area, follow this step until all the desired independent variables are selected. Click OK button, you will see the result, the output viewer window. So the variable in the mode. So this is marital status, sex distributions of person, age in years. This is the variables. So model summary, you will get like this. So that's the different values. You get like this. So now we will get into 30.7, the test of significance. In this section, you will learn one sample t-stat for a mean, 2 sample t-test for equality of means, and e-square test for independence. One sample t-test. The one sample t-test compares the same samples means to a population mean using t-distribution as the standard of comparison. Select Analysis, Compare Means, one sample t-test command for the menu bar. The one sample t-test dialog box appears on the screen. Click on the variable name you want to perform the t-test on the left side box. Shift this variable for box under test variable area. Suppose you have selected income variables for the t-test and the hypothesis taken the population mean income rupees 2 lakhs, type 2 lakhs in the text box, text value. So click OK button. The following is the output you will see in output viewer window. This is the t value for. So two sample t test also you can do. That sometimes our data analysis focus on two distinct groups within a single population, or we want to compare the two populations in the terms of their respective means. The two sample t test for the quality of means will help you in this. Select, analyze, compare means, independent table samples t, and test command for the menu bar. The independent samples t dialog box will appear on the screen, and click the variable name in the left side box that you want to include for the t test. Suppose you want to include income variable, shift this variable to the right side box under test variable using arrow key. Click on the variable you want to group. Suppose you want to test the income mean difference between the males and females. Click on text variable. Shift this variable to the box under grouping variable using arrow box. Click on define groups button. The define group dialog box appears on the screen. Type 1 in the group 1 box, type 2 in the group 2 box. Click continue button to close the define groups dialog box. So you can select group 1 and group 2 from here, and click OK button to close the independent samples t test dialog box. The following table present as the output. So this will be the output value you get for different values. So now we have chi-square test for independence. The chi-square test for testing the independence of attributes is for the categorical data arranged in a cross tabulation. Chi-square test appears as a option within the procedure of generating a cross tabulation. The steps for chi-square test are repeated of steps for generating cross tabulation within the addition of expected counts under the cells and square under statics. Again, from menu bar you go to analyze, descriptive statics, then go to cross tab dialog box appears on the screen. Then select the variable under rows and another variable under column. Suppose you have selected income level, a categorical variable in income levels low and high, variable under rows, and sex variable under column. So click the statics button in the cross tabs dialog box. The cross tab statics dialog box appears in the screen. Check mark the chi-square button. Click continue button to close the cross tab statics dialog box. So click on the cells button in the cross tabs dialog box. The cross tab cell displays dialog box appears on the screen. Check mark both observed if not already checked marked box and expected box under counts. Click continue button to close to cross tabs and cell display dialog box. Crossed, this is observed and crossed. Chi-square test is used to compare the observed result to the expected result. So that when we click OK the cross button dialog box, the output also is generated. So you have the case processing summary, and we have income level with the sex distribution. You have these values. Expected count is 5.6 in male and female, and observed count is only 4. So this is the square test that we get, and we can interpret it later. Okay, so the reflections and actions 30.3. Answer the following questions on the basis of what you have just finished reading. What are the different views available in SPSS data editor? Explain when would you use each of these views. 30.8 Conclusion. In this unit, you have learned the use of the SPSS program to enter the data in the data file and use this data file for the analysis of data. You might have generated a data file using some other database program such as Excel. It is very easy to convert such data files into SPSS data file. This unit provides an introduction to SPSS. You can do a range of statistical analysis for the simple cross tabulations to more complex statistical techniques depending upon the individual researcher's requirement. However, we have tried to explain only simple commands and statistical tools which are more popular in social research. We will leave it to the student to try and learn the full range of features in SPSS. Further reading, we have from NHL and GM Jenkins and Kim Steinberner and T.N. Bent 97 statistical package for the social sciences, McGraw-Hill, Newark, 1979. So now with the software, so many things have been changed now, because even the operating system itself is moved in the higher versions, and definitely the SPSS software also had improved a lot. So we must be updated with what is happening. And in IBM website, one SPSS software is available for a trial download. You can download and try to use it. I also will be checking that and will make a video on that later. Thank you very much.